Basic mastery question 2 is very similar to basic mastery question 1. This is still a simple separable differential equation, and we still have an initial condition to fulfill. So what do? We do the same thing. We straight away write that the integral of, divide this side through, 1 over y, 1 take y, dy is equal to the integral of 1 dx. Right? So all my y's are on the right hand side, integrate them together. All my x's on the right hand side, integrate them together. Okay, so what does that give me? Well, now the problem is actually just in differentiating this expression on the right. But if you think back to chapter 6, we know how to do this. We actually split this up. We could do this by partial. Well, there's two ways. The first way is we could do it by partial fractions. The second way we could do it by completing the square. However, completing the square is rather disgusting, so let's do it by partial fractions. 1 over y, 1 take y, is equal to a over y plus b over 1 take y. So that tells us that y, it tells us that 1 is equal to a 1 take y plus b y. Now this isn't actually equal, this is an identity. It's equal for any value of y that we put in. So let's try what happens when y equals to 0. Then we get 1 equals to a, and then when y equals to 1, we get 1 equals to b. So that was rather easy, wasn't it? So this expression here is actually going to be the same thing as the integral of 1 over y plus 1 over 1 take y dy equals to the integral of 1 dx. Okay, so what next? Well, now we know how to integrate both of these, right? This is ln y minus ln 1 take y is equal to x plus some constant c. We can use our log rules and combine these, and we get ln of y over 1 take y is equal to x plus c, or rather, the absolute value of y, 1 take y, is equal to e to the x times a, where a equals e to the c. Okay, but we aren't finished yet. We need to evaluate what our constant a is going to be, and to do that we substitute in a equals to a half when x equals to 0. So x equals to 0, y equals to a half. What do we get? We get a half. So we get 1 half divided by 1 take a half, and that is actually going to be 1, and that's going to be equal to a. Oh, what do you know? Because a times e to the 0, so that's a. So that means a equals to 1. So this is very good at this stage, but we aren't finished yet because we haven't made y the subject of our equation. And that's a little disappointing, but the truth is, starting from this position, absolute value of y over 1 take y equals e to the x, we've got a slight problem. That is, this could equal to e to the x, or it could equal to negative e to the x because of the absolute values, i.e. y over 1 take y equals e to the x, or y over 1 take y equals to negative e to the x. Both could be right, we don't know which. But what we can do is substitute in this initial value, right? Only one of them will work. And in fact, if I look at substituting in x equals to a 0, y equals to a half into this one, I get 1 is equal to negative 1. So actually this one I can safely reject. And then I just work on this one. This one gives me y is equal to e to the x minus y e to the x. Gives me y, 1 plus e to the x equals to e to the x. And then we get our final equation, y is equal to e to the x over 1 plus e to the power of x. And now we are finished.